Hello, everyone. It's me again. Thank you. Are you still all awake? So let's repeat the thing and let's give a big round of applause to all of you that are still here. Thank you. Louder, come on. Hello. So welcome to this Brave New World talk. I've got here a QR code, because I love QR codes. This is just to understand what you're looking for on a cross-platform solution. So feel free to scan this and just say what you're looking for. Once again, this is public, so I am not responsible for the words that you're going to see there. Hola. It's always a pleasure to be speaking here in Lisbon. I'm Portuguese, so I've got that. You can find me on Twitter or on @X at Mota. I'm an Android GDE. I'm Android and KMP craftsman and advocate for Kotlin Multiplatform. I'm a writer at Codev. I love to travel. I love photography and running. Lately, only the first two. And I'm really happy to be here at DroidCon. I've got a couple of samples, a couple of articles, a couple of source code, and instead of having links throughout the slides, I decided, once again, a QR code. And you can find everything on my link tree. So you can just scan this, and there's the presentation, the source code that I've created for this presentation. You've got all the links from Google, from Android, from JetBrains, everything in a single place. I'm also going to tweet afterwards all of this. So, meet mobile development. So the first question that we have, and doing a bit of following to what we did on the fireside chat, is how to develop an app. So there are a lot of ways that are going to make you to develop an app. You might have an idea of something that you want to build. You might be paid to develop something, or you just want to test a library or a framework or something. And the first thing that it's important, and why I'm mentioning this, is the tool that you're going to select depends a lot on your type of project. If it's a proof of concept, if it's a project that you're going to develop for the next 10 years, 5 years, or so on. Next, it's going to depend also in the team that you have. If you've got just a single developer, you might need to use a cross-platform tool. Or if you have multiple people that you can allocate, perhaps you can have people per platform. Also, the team background is really important. For instance, imagine that if your team has web background, perhaps you're going to use React Native, and you're not going to use a native solution. Next, it's important to understand how much time do you have to start doing your project and to ship the first version. So here goes the timeline. So are you already behind schedule? Are you on schedule? Can you allocate or hire more people to help you doing your project? Can't you? And finally, it's important to understand if you want to target a single platform or if you want to target everything, in this case Android, iOS, desktop, web, and so on. So when you reach this point, we can select a lot of tools. And one of these tools is not like the others because it's no longer here with us. It's called Xamarin, but the rest of these solutions still exist nowadays and are used by a lot of projects nowadays. So this here to say that although we do native development, there are also tools that you can use to make your life easier. Once again, I'm going to advocate Kotlin Multiplatform here, but it's up to you to select any of these tools. I want just to show you something about these tools, and now I'm going to be the dev's advocate, which is I'm going to show you this. I was on Facebook I was in Instagram trying to post something on Facebook. And I'm just going to reply this again. And look to the spinner, okay? And again. So Meta is a company with hundreds of developers, and sharing something from Instagram to Facebook still shows a spinner that existed 10 years ago when I was starting Android development. So that spinner is like 1.5 or Android 2.0 or something like that. And this is important because for me this is the worst thing about cross-platform development, which is sometimes the UI is not updated. Someone didn't build that part of their app and you're still seeing old things. And we're talking about a company with hundreds of developers. Next, we always have this question. This is a Flutter application that was published by this user, and anyone can spot an error here? I'm going to say that this is an iPhone. And the reason why I'm saying this is because iPhones doesn't have this type of dialogues. And this ruins the experience of this is an iPhone, and iPhone doesn't have this type of dialogues, and this ruins the experience of an iPhone user. And remember that when you're building an app, nowadays there are hundreds or dozens of similar apps, and you want to give the best experience to your users. And from something that I've really understood from usability tests that I was doing, is that iOS users, iPhone users, are really picky to their UI. And if it's a bit strange, a bit different from what they're used to, they don't usually like those apps. So, a bit of summing up everything. Be careful with the demo effect, and this is also valid for today's talk. So I'm going to show you that Kotlin Multiplatform is amazing and Compose Multiplatform is amazing, but remember that this is a talk. I've created a sample project to show you, and this might not be the case for when you're going to test it on your requirements, on your use cases. Remember that cross-platform solutions like these ones are framework dependent. Sometimes there are features that are missing, especially if only exists on Android or only exists on iOS. This is an arguable question, but it's a slower performance. If you want to have the same performance, sometimes you need to do a lot of optimizations, but you're going to use time to allocate time to make those optimizations. And you're committing all your code to a single framework, and do we know if from 5 years from now, are you still going to have that framework available, or are you going to redesign your entire project and start using another one? So this is why I'm going to show you the power of Kotlin Multiplatform. So the first thing that is important to mention is that Kotlin Multiplatform, it's an SDK, okay? This is the greatest thing about Kotlin Multiplatform, is that it's an SDK that you can use, and you can give this support for your apps. Also, it's developed in a language that we all love, okay, Kotlin. Okay? Show me the love. I was expecting a bit more. Show me the love. And the goal here is not to share everything, okay? Like all of those other tools, they want to have a single code base that you can share across all platforms. Here, the goal is to share the business logic. In other words, what makes sense for your app. So instead of building your network requests in Retrofit on Android or Alamofire in iOS, you're going to use Ktor and develop that once. You decide what you want to share. So I mentioned network requests, but you can share just your DTOs, your objects that can be shared across server, across the mobile apps, across the desktop. You decide what makes sense to share for you. And finally, you can have your UI developed natively, or you can also use a tool like framework like Flutter, or now you can use Compose Multiplatform, and you can also leverage the power of Compose and share your UI. It's up to you, it's up to your projects, you decide. So Kotlin Multiplatform exists for a lot of platforms. You've got for WebAssembly, GS, JVM, native, where we include the desktop, and of course iOS, tvOS, watchOS, and so on, and Android, and once again everywhere. TV, wear, auto, automotive, fridges, if they start shipping for fridges. Supports Android, it supports Kotlin Multiplatform. The question that always asks us, apps in production with Kotlin Multiplatform, there are hundreds of applications nowadays on the store. And once again, the question, what to share? And I want to give emphasis to this point because when we learn some new technology, we always want to make big refactors. We want to use that. I was talking here before, and there was a good expression that was hype-driven development. And okay, there's Kotlin Multiplatform, I want to share everything. There's no need to share everything. My advice is not share everything at first. Okay, you're going to learn a new technology. Your team needs to be comfortable with this new technology. iOS developers need to be comfortable with this new technology. So start by sharing small things. Start by sharing the objects, as I mentioned, or start by sharing the network requests. Start sharing small, and if you feel confident, keep adding new features to it. one of the things that we also use for convincing iOS developer is share your databases. You can use SQLite for this, or you can now use Room for this, as we keep having more support from Google to Kotlin Multiplatform. So in the common goal, different apps share different features. How to share? I'm going just to give you a simple example. When you look at Kotlin Multiplatform, you already have a specific set of libraries. And if you look at the last service that JetBrains did, the libraries increased a lot. So we've got an exponential curve with the libraries being launched. Just a small examples, we've got a couple of libraries that are created by JetBrains. So we've got the coroutines, Ktor, serialization, datetime, and the libraries that nowadays we keep seeing from the community almost gives you everything. Okay, you've got the multi-platform Swift package, you've got Coil, you've got Reactive, you've got WebRTC KMP, the Material Tree, Clock, OKIO. You've got a lot of people, a lot of companies creating these libraries that start to have a lot of traction. And when you're going to start developing for Kotlin Multiplatform, nowadays, I would say that 90% of the times there is already a library that have support for Android and iOS, and of course desktop. How to share? Add support for platform-specific features. When you talk about Kotlin Multiplatform, there is always a joke that you need to use expect and actual. So how does this work? Imagine a simple example here. I'm running my app on an Android and I want to see Android written. If I'm running my app on iOS, I want to see iOS written there, on desktop, and so on. So the way that we have to do this is we're going to use the keyword here, expect, and we're going to define this on a folder called common main. Common main, there on top, it's where your source code exists. Okay? All your code now is inside the folder common main. Next, since we're targeting Android, iOS, and desktop, we're going to say that what we expect someone to define, so we expect someone that's going to define name, and actually, and now if you see there, we move to Android main, we're going to say that name on Android means Android, and for the rest of the platforms means the platform name. As you can see, I'm moving from folder to folder, so I was on common main, where I've got my expect declarations, and then I'm going to be on Android main, desktop main, and iOS main, where I'm going to have my actual declarations. Now, if I'm going to run my app, it's going to look like this. So how to start? We're going to have a great workshop today about Kotlin Multiplatform. I'm just going to give you some simple solutions to start. So there's the Kotlin Multiplatform plugin. If you start Android Studio, now you have got templates for Kotlin Multiplatform and Compose Multiplatform. You can also use Fleet by JetBrains. It's the IDE that has support also for built-in iOS development. You can also use the Kotlin Multiplatform wizard. So imagine that you want to target Android and web, for instance. You can just click on those checkboxes and hit download, and it will generate the project. You can select the targets that you want directly from this wizard. And of course, there is a really cool project created by TouchLab called CampKit that already has support and already has libraries declared. We've got Ktor already declared there. So it's basically a skeleton of an app, and you just need to develop your features. So challenges that you're going to have, because not everything, of course, it's a breeze. So Android, everything is a breeze. For native, these for me are my main pain points. So first, you need to teach iOS developers, if they're going to build for Kotlin Multiplatform, the environment setup. They need to get used to Android Studio. And I don't know your experience with your friends, but typically iOS developers really love Xcode. I'm still to understand why. But they need to learn how to use a different IDE that sometimes they don't understand that easily. Also, you've got higher compilation times. If you're going to compile your frameworks for our iOS, this is going to take you more time than it usually takes if you're going to do things for iOS natively. There's no direct interoperability with Swift, and if you want to have multiple frameworks that are going to talk with each other, you need to have an umbrella framework, meaning that all your frameworks need to be inside one framework. So desktop is quite simple and quick to support. It's quite similar to Android, and you don't need to care about anything. What can help you with these pain points? Basically, there's a really cool tool that I like, which is the Key Doctor. That's going to check if you've got your environment set up, if you're ready to develop for Kotlin Multiplatform. It's on Kotlin GitHub. You just need to download it, run it, and that's it. Higher compilation times, my first suggestion is only compile the frameworks that you need. So by default, it's going to compile, debug, and release frameworks. You don't need to compile both if you're just going to compile it to your device. If you're compiling to your device, you don't need to compile for the simulator, so you can select just the target that you want to compile. And with this, you're going to reduce a 20-minute time to 5-minute time. Also, enable the Key to Compiler, which has a lot of improvements, and you can try to use Kotlin 2.0.10. If I'm not mistaken, it's the latest version, and it has a really good optimizations here. Also, for the interoperability with Swift, Ski by TouchLab, they launched a library that's really good and gives you support to create a better experience for iOS developers. This is not required by default, but if you're using enums, if you want to use flows, and if you want iOS developers to have the same experience that they usually have with other frameworks, my advice is to use Ski. So let's talk a bit about Compose. Compose, once again, it's Kotlin. So it's a language that you'll all love. Once again, it's one of the things that I love with these two options is that you've got low risk. You don't need to decide to refactor your entire project to Compose. You can still use XML and Compose at the same time. There's no problem with it. Once again, start small. Start with what makes sense for your app and keep adding new features in the future. Compose makes you develop your apps faster. It allows you to reuse a lot more code, which is great. And in the end, it also improves your developer experience. You don't have the pains of development with XML. Just out of curiosity, who's using Compose here? Just who wants to use Compose? Okay. Good luck. So there are a lot of applications already using Compose on the stores. You know most of these names. This is just to show you that although Compose is recent, if you compare it, of course, with XML, it has 3 years' time, 2 years' time. We already see big names here moving towards Compose. I'm just going to make a small break here with some Kotlin trivia to guarantee that everyone is awake. So I really like this trivia. So the programming language Kotlin got its name after? That was too easy. That's correct. Next question. Before being called Kotlin, what was the first proposed name for the language? Guesses? Before it was named Kotlin, it had a specific code name inside JetBrains. Yeah, easy. That's correct. And now my favorite one. How many different names did we have for Kotlin Multiplatform? Okay, so we have MPP, then we had KMP, then we had KMM, and once again we have KMP. Yeah. So the right answer is 3 as the declaration names that it was announced. Now let's go to the greatest part here, which is Compose Multiplatform and taking leverage of everything. This is just a simple example of all the main Compose libraries. Okay, basically we've got the Compose compiler, we've got the Compose runtime, and then I just stacked the UI foundation, material tree, material animation into a group that I call the Compose UI toolkit, just to show you that with Compose Multiplatform, basically what happens is we're going to change this Compose UI toolkit from Android to be a version for the desktop, for iOS, and so on. So you still have the compile and runtime, and what changes is this stack. So there's already, of course, applications in production with Compose Multiplatform. These are the ones that were announced during Kotlin Conf and Talking with Kotlin. Once again, this doesn't mean that the entire application is built with Compose Multiplatform. It means that they have code with Compose on an iOS app. Out of curiosity, the first time that I had Compose code on my iOS app, it was when my... can you just cut this video part? I'm joking. When my iOS developers were on vacation, I wanted to try Compose Multiplatform, so I've migrated a settings screen to Compose Multiplatform, and I slowly put it inside of an iOS application, and it took them 2 months to realize that the settings weren't made with Swift UI. It was one of my proudest moments. So there's an example that I really like. It's from Chris Bain, the TV application. Basically, as I mentioned with John, this is also a great example of someone that, Chris Baines, that started developing an application 5-10 years ago, and you keep seeing the evolution of the app, going to architecture components, going to Compose, and now going to Compose Multiplatform. So what can be shared? Once again, the same question. I'm going to say everything, well, almost everything. And we're going to see how we can share all of these things. So first, we've got an application, and if we're going to use Kotlin Multiplatform and Compose Multiplatform, we're going to have our business logic in Kotlin Multiplatform and our presentation in Compose Multiplatform. It's a lot of times the word multiplatform. So typically, we're going to have our databases using SQLite or now with Room. We've got our network using Ktor. This is a library from JetBrains. We're going to use Kotlin X serialization for serializing our data, and we're going to have Kotlin tests for tests. You can also share the tests, which is great because you can only develop them once. Now comes the difficult part, which is the presentation layer. So we want to share all the UI components, and we also want to share all the resources. And typically the resources, if we're using Android, it's r.something. But the r class only exists on Android, so we need to give support for native to not use the r class, but to use a specific version or a specific generation of the r class. So let's see how to do everything. Before we start, I just want to show you a sample that I've built for this application. So let's see if the gods of live demos will work. So I've built here an application that basically what it does is going to fetch images from Unsplash, from the popular site Unsplash. So it's quite easy to navigate. I've got here a navigation. I can search for something, and that's it. And this is an Android application. This code, this UI code that's inside of this folder, that I realize now that you need glasses to see. So I'm just going to quickly increase here the font. Okay, so if you can see here, all this code that you saw, it's inside this shared UI folder. So all my composables are going to be here inside this folder called common main. And what's happened here is that I'm going to have my desktop application, I'm going to have my web application, and pretty cool because now we have support for this resize. Okay, so if the window resizes, it will automatically switch where the navigation should be. And pretty cool, now I have got Xcode here, and I've got my app running on an iPad, and I've got my app running on an iPhone. And the iPhone, it's with a dark theme on, and the tablet is with the light theme on. And you can see that in one case, I've got the navigation bar on the bottom, and in the other one, I've got it on the left. And I didn't need to do anything, okay? This is done by using the new navigation library that was launched for Android, for Kotlin Multiplatform, and a set of libraries already built for Compose Multiplatform. So if we see here, I'm just going to use the adaptive layout, the view model, and in this case, this is for image loading. So this is pretty cool because, once again, I've got the code that I've built for Android. With small things, I made it run on the desktop, and with some other changes, I made it run on iOS, and I've got access to the same features. Also, JetBrains is putting a lot of effort here, and when you try to use the iOS application, you start to find it really similar to the native look. They improved a lot the scroll, that if you scroll your iPhone app built with Compose or your iPhone app built with SwiftUI, there are almost no difference when you're scrolling through a list. And if you check this repository, I have the same app built with SwiftUI, so feel free to check if things look alike or not. So what can be shared? Let's resume this part. So the goal here is we're going to share it across everywhere, okay? Of course, you don't need to share it with WASM, for instance, for WebAssembly, but you can also share it because this is done almost for free for you. So let's start by sharing our Compose elements. So if you're familiar with Compose, or if you're not familiar with Compose, if you want to add text on the screen, you call the text composable. If you want to display an image, you call the image composable. If you want to have a list, you don't call recycler view, you now call lazy column. If you want a horizontal list, you call lazy row, and so on. All of these components are part of Compose, and you use them to build your UIs. So let's see an example. Here it's the structure of my project. So in this case, I've got Android app, the shared logic, and the iOS app using Compose, the desktop app, and WebAssembly. And now I'm going to add a new folder. So I'm going to add a new multi-platform project model. It's going to be called shared UI. And what we're going to have inside of this shared UI, it's once again the targets that I'm using. So you've got your common main here, that this common main contains all your logic, and every time that you want something specific, you add it on Android main, iOS main, desktop main, and WASM. For instance, we're going to see an example that I want to format data, so I want to convert a string to a specific format, and you're going to see how we can do this at the platform level, meaning at Android main, desktop main, iOS main, and so on. So let's dive in common main. What we're going to have inside of this common main, it's all of your composables. So the code that you typically have inside of your Android app, you're going to have all of that code inside of your common main. So in this screen, that it's the about screen, I've got a text. You're going to call the text composable. Spoiler, you're going to see res.string. We're going to cover that later on today, but typically you just need to call your composable for the text. This text is in the middle of the screen, so I'm using a column just to center this text in the middle of the screen. It's the exact same code that you're going to run on Android, you're going to have inside of this common main. Next, this is valid for all type of composables. If we go to something a bit more complex, like the text field, in this case I'm using the outline text field, and this text field is when I click on it, it opens the keyboard and allows me to enter text. So if you want to have this composable shared, you just once again need to have it on your common main model. Okay? Once again, all of your code, instead of being on your Android app, it's on your common main. All of your composable, all the calls, you've got them here. Next, there's a question. Okay? Usually when we have an image that we're going to fetch from the web, we're going to use a specific library for this. You might use Glide, Picasso, Coil, and so on. If you want to do this multi-platform side, you can use Coil3. Coil3 has this support, or you can use Compose Image Loader by KDSFHDV. I'm going to use this Compose Image Loader. My main reason why I'm using it, it's because it was the first library, and it was also the first library that gives support to WASM. Okay, there's no big reason behind it. It was the first one, and it's keep developing for multi-platform, and yeah, since it was one of the first one and it worked, I'm still using it. Of course, you can also use Coil. You just need to use the version number 3. this is fairly similar to what you do usually with Compose. So the difference here is that you're going to use remember image painter from the library itself. So I'm going to make the import from SQL image loader, and then I'm going to use the composable from the Compose library and say that the painter is the one that I have on top. So it's the exact same code. What changes here is the import. Or if you use coil, for instance, it's going to be the same code that you're familiar with. Now we reach a big question here about navigation and about view models. So the first library that I used was called Pre-Compose, and I think it's worth mentioning a bit more because this user here, Talster, he was the first one to give the support for live data, for navigation, for view models. And this has been my main library for multi-platform development for quite some time, especially because he really liked what he was doing and he answered all my questions, he solved all my issues, so he has a special place on my heart for him. However, we keep seeing new developments, and now with the releases from Google, I've made the switch to use the Google version or the JetBrains by Google versions and moved a bit away from Pre-Compose. There are, of course, other libraries that you can use. You've got Decompose, we've got Voyager, but currently my advice is to use the navigation suite and to use ViewModel by JetBrains/Google. How can you do this? This is quite simple. You're going to add these two dependencies, and an important thing here on dependency is this is inside of your build.gradle file, and you can see that I'm adding that on common main. I'm adding that on common main because they're going to be used by all the platforms. If there was something that I was going to use only on Android, I would use it on Android main, and only the code inside the Android main folder would have access to those libraries. So now if I want to add some navigation, and remember that we have support for the navigation on the bottom and on the left using the navigation rail, all for free. What I needed to do was to define the items that I want to show, a list here, and then I can just use the navigation suite scaffold. I'm going to iterate with my list of items. I'm going to add an item, and basically adding an item here is just adding an icon and adding the text of that icon and saying what will happen when the user clicks in one of these buttons. So if the user clicks, I'm going to update a remember variable, and I'm going to say that the new destination now is going to be when the user clicks. When this changes, I'm going to load home content, which is the first screen, or to load the second one. And with these 50 lines or so, you've got all the support that you saw. So you've got all the support for having everything on portrait here on the bottom or on landscape here. And this even on iPhone or iPad. So next, what about platform specific? Once again, we take advantage of Kotlin Multiplatform, and the example that I was mentioning was, imagine that we've got a string that's going to be a date, and you want to format according to, just want to show the time or something like that. So we're going to start by defining expect, okay? Because this code is going to be on common main, and we want someone to define what it is. And we're going to use the Java version for this. And since we're going to use the Java version, we need to have this code only on Android and on desktop, okay? And with this, we have access to the entire Java SDK, similarly as you would have on Android. And we can just call date and then simple date format to format this date. Next, if we want to do things natively, we can just call the foundation. So a bit similar to what you do with iOS, you can just call directly NSDate, NSDate formatter, and you can format your date on native as you would do on iOS development. Of course, using a language that we all love, which is Kotlin. So everyone. Is there any iOS developer here? Okay. We also love you. What about resources? This is the most tricky part. So when you talk about resources, also it's worth mentioning that there is a library called the Mocha resources. Mocha resources was also my main library until a few months ago. They nowadays are once again active, so they released a version last month, if I'm not mistaken. But the library started to have a lot of tasks to copy assets for iOS. So I recently updated all my projects to use Compose resources from JetBrains, and I've been really happy with the result because it has been working almost since day one. So my advice here, if you want to share resources, use the Compose resources version by JetBrains. So what happens here is we're going to our project structure again. We open common main, and now we're going to have a different folder there called Compose resources. So basically, this is your res folder that you have on Android, but since it's going to be shared, it needs to be called Compose resources here. And here, now you're going to have the structure that you're already familiar with, and you can have your drawable folder, your font, your values, and so on. So you can just almost move your files from res folder here to Compose resources. So let's see how we can use strings. So you're going to use the same string files that you have on Android. So you've got your string XML file, and you can just use it inside of your project. In this case, you're still using string resource, but in this case, instead of using the Compose version, you're going to use the version from JetBrains. Okay? So here, you're going just to replace the import, and you're going to have access to this specific function. Also, you saw this before, but instead of using the R class, now with Compose resources, it's going to generate a res class. And this res class is what's going to allow you to have your strings on Android, iOS, on the desktop, on the web, and so on. Also worth mentioning that it's string, not strings. This is something that I've yet failed to learn, because every time that I'm using this, I still write strings, but it's string. Don't really know why. If you want to load the font, it's quite similar. So you just need to have a font on that folder, and you can just load the font. However, this font family function is a composable one, so you need to declare it directly on the text. You can't declare it on the typography as you usually do. So you need to declare it every time that you want to use it on a text. My answer to you is just create a composable text that loads that font, and instead of calling the native one, just call your own text. Finally, talking about images, you're going to load once again images. The difference is you're going to use Painter resource from Compose resources instead of using the one directly from Compose. Once again, you're going to access the res generated file and not the R class. So how to call your shared UI code, and this is just to sum up everything. So what I usually do is, in this case, I've got a view model, and I want to set my theme and prepare everything. So I create a composable that I usually call app, and I put all of this initialization inside it. This is still inside common main, and this is going to be the entry point for my app. And what I'm going to do now is I'm going to go to Android. And when the Android opens, it's going to call the one created, you all know. And inside of the set content, I'm just going to call app. And it's going to load everything that I've got on my shared UI. Now, if I move to desktop, in this case, there is a main.kt file that's going to be called with a main function inside. So what you need to do is you call application, you define how the window should be, so the size of the window, the size, and the title, and you call, once again, your app function. If you go for iOS, here it's a small difference. You've got this code is on Swift UI, so you've got your content view.swift, and what you're going to do is create a function inside of your iOS folder, and the function is going to be called Compose UI View Controller, and there you called app. And what you do on your content.swift, so on your Swift UI, you just need to call the main view controller from the function that you've created. So this is, I'm seeing your faces, so I'm just going to show you pretty fast. So what you do here is you create a file called main view controller, and you just call the Compose UI View Controller and call your app. And this code here is called from Swift. So you've got access to the code that you've created on Compose. And with this single line of code, you've got access to the entire app that you've built. Easy, right? Be careful with the demo effect. Don't forget it. On WebAssembly, once again, it's fairly similar. So you've got the main function, and here you call the canvas-based window, where you define the title, you define the canvas element ID. So you're going to have an index.html that you need to say where that your code should be loaded. So this is the ID that you have there, and automatically it will load inside of it. So what's missing? So there are, of course, this is still under development. iOS, in this case, is on beta. WASM is on alpha, if I'm not mistaken. From my point of view, there's still low accessibility support. So if you want to give support on native, there's still some things that needs to be improved from JetBrains side. The Cupertine team is still work in progress. We've been seeing on the latest releases a lot of development, but there are still small things that need to be done. There is no support for Apple Watch that I'm aware of. So if you want to share your code with the watch, it's not yet possible. It will be in the future, but not yet. And yeah, it's still on beta. Once again, there are apps in production using it, but it's still beta. About WASM, we're starting now. So we see that we can have a site working. But once again, this is a simple example. The size of the site, it's not that comfortable, so it's bigger than it should be. But in any case, it's good for a proof of concept and to have a platform for free. And it's still on alpha. Why should you do it? The reason why I switched to Compose Multiplatform is, I don't know if you're aware of this, but not everyone has an Android phone. Yeah, I didn't understand also why, but there are people with iPhones. But those people with iPhones really love the Android work and wanted to test what I was doing on Android. So I basically give support for desktop for the Android app. And with this, they could test the Android app running on desktop. It wasn't my smartest idea because they could also create issues for bugs that I have on the Android app. But the cool thing is that quite easily, I think it took me 1 week, 2 weeks, to give this support to desktop. They could easily use the app. And also, this means for my company that they were able to sell this app. Like I've spent months working it when I could just easily port it to Android, to desktop. Also, new platforms are the way to be supported. Usually, people go for Compose Multiplatform when they have the Android app and not yet iOS app. But it's also valid for if you have an iOS app, but you've got more Android developers and you want to easily ship more features faster. So, some key takeaways, really simple. This is my opinion about the current state of multi-platform, so I'm giving 5 stars for everything. Kotlin Multiplatform is you reach a point of stability where you can use it in production without any problem or any big problem, let's say. Once again, JetBrains answers really fast on the Kotlin Slack, so if you have any question, you can go there and typically in a day you've got an answer, sometimes in hours. There are a lot of libraries out there, they're really good support. And about Compose Multiplatform, I'm going to give it 5 stars for both Android and desktop. Native, since it's not yet stable, there are small things that aren't yet there, but they're really doing a good job and you can start having your apps on iOS. WASM, WebAssembly, we're starting it, and yeah, Safari announced the support for WebAssembly, so things are also moving towards it from the browser side. So I've got all the links here. You can just scan this QR code and you've got access for everything. Thank you so much. I don't know if we have time for questions. No? No. Okay, so I'm going to be here. If you have any questions, feel free to reach me. And thank you so much for being here and see you around. Thank you.